All right, hello everybody. It's the Native Resource Management um, work stream for Kubernetes Workgroup Device Management meeting. Um, uh, Ramin, it's or Francesco, I guess. Jump right in.
Hey, hello. So, Praveen, do you want me to start?
Yeah, you can go ahead.
Okay, thank you. So, um, I'm playing with the DRA memory driver, and we have a rough consensus. Then, once this work gets more stable, and the CPU driver gets its own, it's start to run out, we'll start to talking about convergence. So this is mostly a researchy project, and in that context, I was thinking about the claim sharing semantics, especially for memory, because okay, please keep me honest there because I'm not so experienced yet in all the DRA nuances, but basically by default, containers and pods they can share claims. So it's enabled by default. Meaning, okay, that's fine for devices. I see no problems. That's fine by CPUs, even though I believe in the CPU driver, we want test and documentation to say, okay, this works because we want it to work, and those are the boundaries. But for memory, it doesn't work too well. And this is not a concern now, is not to be a concern next month, but is something that has to be on the radar. And why it doesn't work very well for memory? Because memory is anonymous. You cannot ask, hey, I want to get the exact same huge pages this other guy is got. There is no way to do that. It's same for memory. Okay, this other guy got 4 gigs of memory. Fine. I want to get access to the exact same memory for whatever reason. So it kind of devolves in a quota mechanism in disguise because both containers, for example, get access to the same claims, so they 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 cannot access the same memory, not easily at all, at least. So they kind of fight for the same memory quota, which is pl plays very badly with the semantics. I am aware we want to enforce. So with that in mind, my take is simple. Up until we figure out, we just disable sharing for claims, and the question becomes, uh, is there a simple way to disable claims somehow, or for I don't know, a resource size attribute which I didn't figure out, or do I have to implement that in my driver and error out if I detect there is someone trying to share?
So the short answer is the second one right now, right? Like we basically we don't control it at the API level. Um, the so we have two ways to share a resource, an underlying resource right now. One is through um, shared resource claims. So you have a single resource claim that owns the device, and that resource claim can then be shared by multiple containers or pods. Um, and there are exactly zero controls on that at the API level right now. So we early on did have a flag basically that would control at the API level whether a claim was shared or shareable or not. And we just decided it was extra complexity that we didn't have specific use cases for at the time, and we just left it off. Now we have, so um, the other way we have of sharing a device is through the consumable capacity, which actually that's a slight misnomer because the cap enables really multi-allocatable, I think is the way we phrase it elsewhere. In that case, the same device abstraction that lives in a resource slice can be shared by multiple resource claims. You could in turn share those resource claims among
Mm-hmm.
containers and pods. So it's
Mm-hmm.
actually a two-level thing.
Mm-hmm.
That one's more controllable. There's a sharing policy. You can say whether it's multi-allocatable or not, all of that. So um, for the first one, we probably should add something. And
Hmm.
so for now, what we do is just it's up to the driver to throw an error
Okay.
when somebody else tries to use it. We have exactly the same problem for network like network
Okay.
interfaces. They can only live in one network namespace, so like you can't share them among. They're automatically shared among all containers in the same pod, and you can't share them among pods. So like
Okay.
they're different animal. So that's the short answer for you. So I'd
Yeah.
love to see some development in that area, but the fallback is the driver.
Oh, okay. Okay. I see a one hand raised.
Yeah, Francesco and John, if I understood your use case, I'm just wondering, I mean, it is possible if you use memif as they do it in the VPP FDIO, correct? So you can actually share a specific memory, and then it will be exported like a Unix socket, and then, if my understanding is correct with the DRA, it should be possible to explicitly share an area of memory utilizing memif, mmap, and FDIO VPP kind of approach.
So there's other, yeah, like so I know also Sasha's not here, but he's talked in the past about technologies coming along that would share memory. I don't know if it's using that technique or traditional shared memory in Unix. Like there's ways to share memory. What's missing now is since there's no controls, like we probably should think through like do we want to define certain types of memory devices that are shared memory and they have sharing as a possibility through one or more of these sharing
Eh,
mechanisms? How do we
yeah.
control it? All of that.
Yes. Yes. This is the angle I'm coming from. The angle I'm coming from is there surely are meanings to share memory. They are. But if we extend the current model, and okay, we start modeling what we have today with DRA, like, okay, memory or huge pages, they don't have a name attached to it, and attach it carries extra baggage. So should those should be, in my opinion, at this point in time, this should be even different resources. The default resource like we have today, like memory and usage pages, those are anonymous, and naming them it's challenging. So this is requires the simple extension is anonymous memory.
Right.
It,
So,
going to
so
named regions is much more complex and endeavor and is a departure from their current model, which I'm totally open to, but it's, quite a diversion.
I mean, I think the simple things should be simple, right?
Yeah,
Right. And the complex things can be complex. Like,
yeah,
so one way to imagine that or to explore would be like, right, that the pool of anonymous memory, depending on the technology, the pool of anonymous memory may be you may be able to draw upon that to create some sort of named segment that then can be shared.
yeah.
Like, and then you have to do the accounting that the pool of anonymous memory is reduced. It's actually not, I mean, it might be a little bit like, just when I describe it that way, like we also have in the CPU side, right? We have, hey, we want to create an exclusive set of CPUs that then we could share. We also have like an anonymous pool of like unregulated CPU access, like, and we have a similar, maybe it's similar
Hmm.
thing. So I think it's important to start exploring that now, and let's try to get some understanding of what new modeling features we need and new sharing controls we need to make this work.
Uh, I'm at this point in time, I believe we should default with anonymous memory and anonymous huge pages and evolve from there because, in quotes, just in quotes, reaching the point we can model that and consume that with the array will be in conjunction with CPU will be a huge leap forward.
Oh yeah, yeah. I
And,
agree 100%. Yeah.
But yeah, I'm 100% agreeing that yes, there are totally ways to have named memory, but this thing is something that we should address much later, I believe. So for the time being, documenting the decision, which is going to be relevant also when we start talking about the merging the memory feature in the common core resources driver, and then at that point. We can evaluate, and I'm fine just in quotes again, error handling with an error in the driver. That's completely fine by me. And okay, so yeah, that's my take, and I think it's good to put that on the radar, but I'm not saying we should that should consume bandwidth at this point in time. I'm open to be corrected if someone disagrees.
I haven't heard a burning use case for it yet.
No, exactly. I don't think there is. I mean, the covering the basics, like, okay, nice, we can handle core resources is going to be plenty of work for the coming weeks, probably months. So, yeah. Mm, I mean, in the roadmap for sure, and this is the reason why I mentioned that, but I do think that besides that, for the short term, say, okay, sorry, you cannot share a claim which includes memory. That's the other part which I wanted to mention. So if you have a claim which is
Mhm.
for CPUs and memory, tough luck. You can only have one claim per memory. You can only one. We have one-on-one claims and containers and not even pods for memory. And if your claim includes memory, you are out of luck. This is the other takeaway I have for this forum. Anonymous memory.
Yeah. So part of the discussion that we had last time was around um, creating different um, accounting, different life cycle. I'm going to call it life cycle. It's not quite accurate, but events in the use of a device or a claim, then accounting for the resource consumption when one of those things happens. So allocation is one, but then sharing was another one. And we actually discussed having a separate, being able to account separately. So, for example, if you've got a device and you use a resource claim to allocate that device, and then each time you share it, the driver needs to allocate a buffer, right, for that particular
Hmm.
workload's access to that device. We talked about having a place within the API where the device vendor could
Hmm.
specify, hey, whenever this is shared, you need to allocate this much. So with that mechanism, you could potentially share a claim that has a memory thing. It's just that you'd consume that much memory again because you instantiate another
Yeah.
separate memory. So that could be a way, like a first step towards it, that it doesn't, it's still always anonymous, right? We're not doing named shared memory segments that actually you can, but it's like each time you share this claim, you get a duplicate of this resource allocated or whatever, and you get some part of it is shared. So we'll have to think. There's like these are all the things we have to think through in like the
Yeah.
work that Praveen is doing. So
Yeah. Okay. Yeah. The only thing, and the last thing I'm going to mention, because I realized I left that implicit, is that for the first iterations, or maybe in general, for anonymous memory, we totally want consumable capacity because it makes little sense to model without it. And so the other basically, yeah, it boils down that the only way to prevent sharing initially is going to be detecting the driver that you're sharing a claim, and no, not yet. And yeah, and that's it basically from my side.
okay,
So
Thank you
the
all.
proposal is not to allow such memory sharing, correct?
For the first alpha, which is the stage we are now, yes, and I would say I would actually uh, come even forward and say, okay, initially, if you want to share anonymous memory, the anonymous memory model as device, we will like to see the use case to understand the boundaries. Because, like, exactly for the reason you mentioned, if you want to share the memory, you need to allocate differently. It's not the out of the box solution.
Today in Kubernetes for like traditional shared memory access, is that has to be the same container or processes in the same container or
Oh, actually, I don't think
Uh,
we can out of the box. I mean, with resource request, you cannot really do that. So you have to
it,
jump.
it, it is possible
Is this?
already today with the MEMIF and the VPP.
Ah, okay, yeah, but not
Yeah,
it's
yeah.
not so,
So
it's not a resource that Kubernetes is aware of.
I think, okay, I think CNI vendors, they already have it. And there are some papers from Intel which they demonstrate that it's actually, there is a use case for this.
The use case it is, but it's not something you say. There is not, there is the resource use page, there is the resource memory, but there is not the resource memfd ma baked
so
memory.
like Kubernetes can't manage the accounting of it basically right now?
Okay.
Is that what I mean? I'm actually asking. Like from my as far as I know, it doesn't. But
Exactly, same here.
okay,
But we can continue offline. I don't want to steal the show. I mean,
okay.
I'm
Well,
totally
this is a
open.
light topic. I mean, this is this. I don't think this meeting is so. It's all about this is all about the same stuff. So
Okay, so but look, anyway, Sotiris, if you want to chat about it, totally, because this is the very first, okay, basically the idea is that we don't know yet how to handle that. So my take is that instead of of having undefined behavior and let the user figure out, I would prefer to say no, this is not yet supported because we don't know how to model it. So this is totally subject to change. So if you want to reach out and chat it further, I'm all very interested into. Yeah, on other end, I see.
Yeah, sorry, I missed the beginning of the discussion because of a conflict with meetings. So, Francesca, what is the problem you are trying to?
Mm, The the problem is that we were talking about the sharing semantics for memory claim in the context of the researchy DRA memory driver, which I'm doing. So basically, the thing is that, okay, at this point in time, we are dealing with anonymous memory. You cannot really share anonymous memory out of the box with the resources Kubernetes is aware of. You can share memory. There are many ways in Linux, but in Kubernetes you cannot ask yet, like, hey, I want to access the same container this other, I want to access the same memory this other container got. You so
So,
in the driver, I would say, okay, since we are not sure about the use case, we're not sure how to do that. I just want to disable it, and we're discussing disable it. How the best way to prohibit to and disable them, and then we started talking about the use case and memory sharing in general and other things.
I have a use case for that explicitly because of
Mm-hmm.
a CXL attached memory. So,
Mm.
so practically, it's a dynamically attached memory. You have
Mm-hmm.
a like fabric manager where you can allocate portion of let's say like few gigabytes of memory. It
Mm-hmm.
get dynamically attached to the node. It will get its own NUMA node. So then
Mm.
you can pin the container to specifically to those NUMA nodes, or let's
Mm-hmm.
say not really pin, but like allow to access the memory from this region.
Okay.
yeah.
Oh, go on. Sorry.
Oh, so yeah, I was gonna say, yeah, that I think that that's something we should explore for sure as a use case. I think that what I was saying earlier was that it would seem to me that that's we probably have different types of memory, so almost different devices that may be allocated out of a common pool, maybe don't. In this case, CXL it wouldn't be a common pool, and then right, it has very different semantics than ordinary memory, so it's not necessarily the same driver, um, but
for application, it looks like a normal memory. And actually, the whole system will see it as just a one more NUMA node, like CPU less NUMA node.
But the provisioning of it is totally different.
Provisioning, yes. That's why we need actually DRA driver. So we need to prepare it once it's ready, and when we need to allow like C groups access to it once the container is started.
Okay, this actually doesn't surprise me because I'm very open to review this decision. But initially, I mean, for first alpha, I still prefer to disable. But that's a very good use case, and we can get in touch and talk about it.
For us, it's one of the main use cases because devices, I mean, like the CXL devices are expected to be available for OCP community, later this year.
Okay, fine. So this means that we can talk about that and as the next iteration right after the very first release and think about how to start doing with that. Yeah, that's a good idea. I will get in touch soon enough. Thank you for sharing.
Do we want to try to get? I guess what I would ask is that from a design perspective, Sasha, we need to, right? 136 cap freeze is in like 30 days or something, right? So we need to ensure if there's any API changes specifically, or if we need to, like if you're talking about having something this year, right? then alpha in 136, maybe if we were really lucky, a beta in 137, more likely a second alpha in 137 and a beta in 138. So like getting, if there's an API change or an API we need as part of the use case you have, and you want to have something in beta by the end of the year, we really need in the next 30 days to figure out what that API is. It's not necessarily the same, Francesco, of the issue you're dealing with, right? Of anonymous.
Yeah, no, but I'm interested and I agree.
Yeah. Okay.
I just want I probably don't need to be in the beta by the end of the year. As I said, like the vendors who are producing the CXL devices were a bit slow. Like the CPU side for this kind of features already present for, well, more than a year. It's more than the question of, if we will try to prevent something right now in the first iterations on API level, that will cause us a problems later on.
No, we're not preventing anything on the API level. Basically, Francesco's saying, hey, I don't know what to do if somebody shares a memory claim and I've got memory in it because I can't share it. And we're saying for now, the driver will error out if somebody shares a claim that's got memory.
Nice summary.
Well, if it's driver decision, it's fine. But if it's API server decision, I'm not fine.
We don't have a way to do it in the API server right now.
Yeah. Well, that's what I was trying to say. Like, don't create artificial blockages for these kind of situations. So if driver is not able to handle it, that's fine.
No, exactly. This is totally the angle I'm coming from. I was asking initially if there is a way into resource slice to say, okay, this thing we should not be shared, but it was kind of confusing because it's something that at this point in time we want to use the consumable capacity, which could prevent the sharing, but at the same, to model memory now, the easiest way is to use it to consider it anonymous and use it consumable capacity. But at the same time, there is no flag, as far as I'm aware, in the API to say, okay, no, but you cannot share claims, okay, with that. So I'm totally fine to handle that in the driver as a short-term solution. This is something that, by all means, will need more work, but as a starting point, exactly as John summarized, I don't know how to handle that. If we ever could share these specific resources. So the default boring anonymous memory, so just erroring out.
Yeah, my question about this API driver discussion, I mean, Are we planning to have the support of multiple DRA drivers to be used? Correct?
So a claim can have multiple requests, and each of those requests is nailed to a specific driver for practical purposes. Technically, right now, requests have a device class, and a device class actually could be satisfied by different drivers, only one at a time. But practically, nobody's doing that. So maybe I'm just confusing matters by even mentioning it. But the the claim itself, because it has multiple requests, right, can be for a whole constellation of resources that are satisfied by different drivers. So if one of those drivers can't be shared, then that claim can't be shared. I don't think that's a problem right now, but that's the way it works.
Okay, makes sense. Thanks.
Marlo?
Hi. I think we could potentially have the request filled by different drivers depending on the node it's on. So if you have an Intel architecture or an AMD architecture and you have different behaviors, I could see that
Yeah,
being the same.
especially for memory and CPU.
Yeah. I'm thinking specifically for that area, not for
And for NICs too, you could have the same.
and for NICs as well. Yeah, the question I have that I still don't have really good clarity on is how we're going to get rid of that 32 device per pod limit that we have now.
I think Morton's on. Morton, is the 32 coming out of, I think it's 128 now, or 200. This is about the reserve for, or this is I'm trying to remember which specific one this is, because we had.
This is the limit on the number of devices that can be allocated to a single claim, isn't it? That's what we're talking about now, not the reserve.
Okay. So this is, it's not, so this is the, do we list, this is a 32, this is in the resource claim status where we list the number of we list every device?
Yeah, I think so. I don't think we've had any real discussion about changing that other than, I think that's an issue, but I think that got more focused on the priority, resource slice priority, which I'm looking at, but I don't think we have done any real action on the raising the limit.
So I think I know why this is a problem for you, Marla, because you want to use the per CPU variant of modeling, per core variant of modeling, rather than the capacity pools.
Correct. It's needed for scheduling for the Slurm scheduler, because it does use that level of granularity to get the performance.
I think we can do the math on. I don't think we're all that worried about the size limits on the resource claim here. It's a resource slice that has been the challenge when it comes to the SCD size. The challenge is that that's come up is the performance for the. I think this doesn't apply for the Slurm case maybe, but for the regular case with the kube scheduler and the DRA implementation, like even 32 devices is likely just performance issues that will take years to allocate.
Yeah, no, I got it. So the way we're pulling the information in theory directly from the kubelet, not kubelet, from the API. So that will still have to have that throughput, but the computations underneath we're fast at. So if the issue is not the API behavior, then we don't care.
You would tell. So are you going to do? So this is something that came up. Maybe I'm veering off topic. And Praveen, if you've got topics and I'm taking over, then just yell at me. The one thing I was wondering about is today, resource claim allocation is always done by the dynamic resources plugin, but couldn't, if we wanted Slurm, for example, or some other scheduler, to take over that complete allocation, right? So rather than, so one way, what we've talked about in the past is, hey, Slurm can look at the resource claim and it can process and add a bunch of cell constraints or other constraints to force the dynamic resource plugin to specifically choose what it wants. So it would add a cell expression that says, CPU ID equals 1, 2, 3, 4. What should we explore? Just allowing you to create the resource claim allocation. Does that create raise conditions in the plugins? Does that cause any problems? Or would the DRA plugin just go, oh, this is already allocated, I don't need to do anything? I mean, you would be your responsibility to make sure you allocate the right things, but you're already doing that, right? So basically, use a different API. Rather than using cell expressions in the resource request to specify your allocations and force the one allocator to allocate it, just create the allocation in the resource claim status directly. This is separate from the 32. Well, the reason this matters to the 32 limit is, right, basically we'd be saying we're going to bypass the dynamic resource plugin entirely.
Yeah, we were still planning to have the driver do that work and just use the scheduler backend.
But the driver.
But the scheduler will say exactly what cores to allocate. So the driver doesn't have to think very hard.
Right, but you're going to calculate which cores to allocate, right?
Yeah, exactly. But once it gets to the node, I need the driver to stick the right things in C groups.
What's your hook point for specifying the exact cores? That's what I'm talking about.
We can change the pod spec to do that.
Okay, so you're going to change the pod spec or the resource claim spec to do that.
Resource claim spec. Yep.
Right. So what I'm saying is, with a scheduler plugin, and maybe that's part of the problem, is you'd have to be a scheduler plugin.
Yep.
In theory, you could allocate the resource claim yourself and bypass the dynamic resource plugin altogether. So basically, you take over, you replace.
Oh, I see what you're saying. Yeah,
right?
We could do that, but I don't know if there's not currently a way to do that I know of.
So it might be an interesting avenue to explore whether we can add that to the scheduler, because it might. One of the issues we have is the dynamic resource plugin is very naive in its allocation mechanisms, and we're building a bunch of APIs that control kind of how these accounting mechanisms all work. And the APIs have to be understandable and consistent across all ecosystem components. But the dynamic resource plugin doesn't have to be the only thing that can actuate those APIs, right? That's kind of my point. Like maybe we can have a plugin mechanism as long as those APIs, as long as like an auto scaler or something can deterministically predict the semantics of those APIs. It doesn't matter whether it's the existing dynamic resource plugin that satisfies the APIs or something else, as long as it all works in a flow. So we haven't really talked about that as an option in the past, and I don't know what it would mean in the scheduler architecture to do that, but I think it's worth exploring.
But since you mentioned to satisfy, I mean, thinking out loud, if you're going to have multiple resources to different devices, then someone needs to ensure that there are not going to be any race conditions, or that everything will be like an orchestrator. I mean, so this, which one will it be? Is it the API or?
Well, the way it works today, there's not really. The way it works today, the dynamic resource plugin basically goes through its job is to allocate the resource claim. And the algorithm it has is it goes through each request in the resource claim, and the drivers have published enough information to the API server that the dynamic resource plugin can have sort of a consistent set of logical rules on how to allocate any one of those requests. And so it does a depth first fit algorithmic search of the entire solution space. So if you've got 4 requests, say for CPU, memory, NIC, and GPU, and because they're all in the same claim, you can actually specify constraints across those 4 requests. Like, okay, I want those and I want them all to be, adjacent to the same CPU socket. That would be a constraint. And so then what does the dynamic resource plugin do? It starts with the first one. It says, okay, give me some CPU. Okay, out of this particular CPU. All right, I can satisfy that. There's enough CPU available with that socket. Okay, now go to the memory. Okay, yes, I can satisfy that. Oh, now go to the NIC. No, I don't have a NIC. All my NICs and that are associated with that CPU, intra-node topology are consumed. So now I have to pop back up the stack, right? So this is the depth first, and I have to go all the way back up to the top and start on the next CPU socket and try, right? And so it's this depth first, and this is what Morten's talking about. This can be really, really slow because it's very naive and doesn't, for example, it tests the constraints along the way. So it's not like it's not like it comes up with a complete solution and then checks the constraints, which would be worse. But it doesn't like say start from the constraint and go, oh, can I, is it even possible on this node, right, to meet this constraint and make that decision immediately, right? It's very naive. So
and the example of the order that you gave, CPU, memory, GPU, NIC, for example, is this will be the order always.
No, it's the order that it's listed by the user in the resource claim. So
if I do a resource claim, and so first one is the first served, then it will be priority 1. So if I want to give more priority to NIC, I have to put it first, you mean?
It's not so much priority. You have to meet all the constraints. We don't have.
But the example that you gave, you started if CPU, then memory, then. Right. So that's my question. Is it going to be like this?
No, if you're right that if you have so that means you can game the system. If you understand this, you can be like, not game it, you can improve the performance of the system by being like, well, I know the most constrained resource is GPU, so I'm going to start with GPUs, and then the least constrained is CPU, so I'm going to put that at the bottom of the list. Like you could do that, but that's like, we don't ask users to do that, right? So, but you could. And similarly, when we're evaluating the individual, say, GPUs, right? We currently just do that in the order that they're given to us by the vendor. So the vendor, take, for example, if the requirement of the GPU wasn't like, I need this specific GPU model, but it was, I need a GPU with at least 40 gigs of high bandwidth memory, then or so smaller, let's say 4 gigs. Well, in a MIG environment, right, a partitioned GPU environment, if the driver listed the physical GPU first, well, I meet that requirement, I'm going to give you the physical GPU, right? Because it's first fit. Whereas if they flipped it and listed the smallest first, right, the 4 gig ones first, it could give you a partition of a GPU. So, right, so it's not great, right? Like there's no scoring. The other way to address this kind of issue is scoring. We haven't introduced that. So there's right now it's like it's all this ordering stuff. So
it's first fit,
depth first search, right? So it's basically the bare minimum, to be correct. Like that's what it is. We do hope to improve those algorithms over time, and we have ideas on how to improve those algorithms. What I'm saying is, the most important thing in all of this is that the APIs specify the resource slice API specifies your sort of palette of possibilities, and the resource claim API specifies your specific workload requirements. And the job of the platform is to satisfy those workload requirements in the most optimal way for the user, subject to the availability of that palette. And with the things we call device classes, you get the administrator has some input on that too, like what they prefer. So like that's kind of like this constellation of functionality. And right now, the implementation of that is dynamic resources plugin. From a high level view, that's just one implementation. And we could have other implementations. And the coordinating, what I'm wondering about is whether the existing framework or what changes we'd have to make the existing framework to allow other algorithms to be plugged into that, maybe only in special circumstances, that bypass that sort of default naive algorithm that's going to be correct but might take a long time, and might not be optimal because it's first fit, and do something better. So like Slurm is an example where they have very sophisticated algorithms for doing all this stuff. They need a way to plug it in. And one way to do that, the way we've been talking about doing that for a year or two is that they would plug in and would make those decisions and would use the APIs at the spec side of things to adjust the spec so that that dynamic resource plugin that already exists is sort of prescribed to allocate in a very specific way. So in its search, one of the first things it does in the search, for example, is it applies a bunch of selectors to eliminate devices for consideration. So if in your spec changes, you add a bunch of selectors, you can actually force it to very quickly come to a conclusion that you want. So that's the mechanism we've been talking about. And I've gotten feedback from like, say, from like Eric, right, Toon, who's working on the workload aware scheduling side of things. And we were talking about, could we use DRA for these multi-node devices that represent topologies? And he found that mechanism too difficult, right, especially in those contexts. I'm not sure if that's true. I mean, Marlo's team seems to be able to do it, but it made me think a little harder about like, what are other mechanisms? One of those other mechanisms I'm wondering about is the resource claim status is actually the output of that dynamic resource, the resource claim allocation, that list of devices that Marlo's worried about that's only 32 long, is the output of that dynamic resources plugin. And can we have a different plugin that under certain circumstances can make those decisions ahead of time? That's kind of, and sort of bypass that completely. And that's what I'm wondering about. Morten.
Yeah. So, but like, even if the spec is specific and only allows one solution, like that doesn't necessarily solve the performance problem, because
not necessarily, but if it's done through I think if it's done mostly through the cell, it will, because it limits the solution space that you have to search pretty effectively. But we'd have to see.
It doesn't really, like, it still goes through all devices and checks them. So if you can still end up,
it shouldn't check the combinations, right? It should. So, I mean, I haven't looked that closely at the algorithm in a year, but like, if I were writing it, the first thing I would do is go through all my cell selectors and eliminate all the devices that don't meet the cell selector. So that's a linear search through the devices.
That's fair,
right?
yeah.
And then I start doing combinations of the things that match those cell selectors. So that's a much smaller set if the selectors are very specific.
Yeah, I think that's right. If you set it correctly, you should be able to only need a single pass through all the devices, and that should lead you to the right solution. I think that's right. And for when you talk about alternative implementations, that's essentially like being able to switch which scheduler plugins run and potentially the order. So find a way to, if there's a way of saying like, don't use the dynamic resources plugin, run this other plugin instead.
Well, no, what I would think is, no, the dynamic resources plugin would get called and it would see that the resource claim is like we already do this. When it's a shared resource claim, we don't allocate it again, right? So I think it might fall into that same, if another plugin has already written that's what I'm asking. Right? We have to go check.
If a claim has allocation field already set, the dynamic resources plugin doesn't call allocate again. I think that is right.
It doesn't.
Yeah.
Yeah, that might be possible. Yeah.
Right. So we're still using the same API surface that we've already designed and built and is out there as GA. We're just altering a bit how we use it. Right.
Yeah.
I'd love to explore that more. I'm sorry. I do think I digressed this whole conversation to something that isn't necessarily appropriate for this call. I'm sorry about that.
Okay, some more conversation to be had, as a Telder.
Praveen, did you have some topics here?
Yeah, I mostly wanted to continue discussing on like the API and the use cases that we were discussing last time. I think we have 9 minutes left, so I don't know if that is enough to like start the discussion. So, but I started working on the KEP, so I have a PR up. I added that in the meeting notes. I also pasted it on the chat here. So if we can kind of review this offline, and I considered like all of the use cases that we discussed last time. Like basically we kind of bucketized into two high level use cases where like one, we have the DRA, I mean like a DRA driver representing like CPU or memory as a resource. And the second use case is like if there is another accelerator driver, but it also wants like auxiliary CPU and memory requests. Like we need a way to specify that as well. I considered both of them, and in the KEP I have some proposal like on the API. We also discussed like couple of options on how we want to describe this in the API. One was like through the device class itself, where we can have the native resource mapping, but we kind of arrived at like doing it through the device API. So what I've proposed here is like basically we have one field in the device class which says like if this driver has or represents like native resource, but most of the information would be a part of the device API, where we specify like what resource it's representing, how to account for the quantity, and multiple models for accounting. Like basically I have 4 of them listed. One is like override, which would be for CPU DRA driver or memory DRA driver. The other way is like we have a request specified in the pod spec, but we also want the request specified in the DRA like or the resource name to add to whatever is already specified in the pod spec. The like the other option is, I think we briefly discussed this last time, where we have a resource claim which represents a pool of resources, and a pod request consumes out of this pool. So basically I've explored all of these options, and I've also explored like how it works with different types of like modeling the resource itself, like consumable capacity and like partitionable devices. Yeah, and yeah, we can review this KEP offline, and I would want to get some like feedback on like the API and if this works for all of the use cases.
It also, I think, I'm going to bring this up with Jordan. I think I have a call with him later today, because I think this is a pretty complicated API, and we need to make sure that API reviewers are going to find it acceptable. So we tend to find that in API review, right, we get a little more pushback on like trying to maintain simplicity, and So Jordan often has very good suggestions on how to do that. So we should get him looking at it soon too.
Yeah, I think it is pretty complicated. Like there are a lot of use cases that we want to address with this API. The other thing that we were discussing was like if we have multiple drivers with different accounting policies, like or yeah, how we want to combine them. I've also considered like some options around that. Like I've added this section called compatibility and validation where we one of the options that I've added is like within the dynamic resources plugin in the filter stage, once the allocation stage is done, we want to like consider all of the claims allocated and see like if in combination they make sense. This is mostly to avoid cases where like we have two drivers which are trying to override the same resource or things like that. So yeah, this is another thing that I've added. Again, I want to get more feedback around this as well.
Okay, awesome. Thank you, Praveen. Yeah, so people can, again, like I said, we have 30 days. I think it's 1 month from yesterday before Kep freeze, which also means a week or so before that, you're going to need to have it ready for production readiness review. Which it should be. Like you don't need every design decision made by then, but you need, the basics need to be there so that we can evaluate, the effect of it on the platform. But okay, so yeah, time is already going fast. So please, anybody who has an interest in this, review it as quickly as possible so we can iterate.
Yeah. Also, currently it's under SIG node, but I was wondering like if it makes sense to add it in SIG scheduling, because at least for the alpha, most of the changes like would be on the scheduler side. So if we think,
I think that's I would ask the SIG node and SIG scheduling approvers what they prefer. I agree that this is primarily a scheduling, like most of the work here is in the accounting.
Even in the future, it will be mostly the scheduling work rather than node. Node changes are simple.
Yeah, so probably should be owned by scheduling, not node.
okay.
I can bring that up, or or go ahead and do it, or I'm happy to do it if you want.
Okay, yeah, I can ask on Slack. Also, I think like in one of the previous meetings, like we were talking about reviewer bandwidth on the scheduler side as well. We would also need like someone to like review.
Oh, that raises. So if you go back to the DRA, that slide I have of like the kind of planning slide, very high level planning slide. I added a priority column there. That's just my take. Like I asked for people to give feedback on that. That priority column was requested specifically by SIG scheduling so that they could prioritize in the context of their reviewer and approver bandwidth. And it's the first slide one. You see the priority is the leftmost column. And, you're down here as a P1, but almost everything's a P1.
Yeah.
I had put one P0, which is the extended resource stuff, because we really need to get that closed out. And I teetered on some of the others. But this is my take. Please give your input here, folks, everybody who's on the line. But this is the priority order they're going to use to prioritize their reviews. And I guess amongst the P1s, it's sort of like roughly rank ordered. But
can you please share the link for this slide?
Yeah, I can. Let me also add it in the meeting notes.
And then I would put a comment on native resources where it says node and just put scheduling, or not, put a comment maybe in you can tag Dominic or somebody from Sync Scheduling. I don't know.
Okay, I'll do that.
Yeah.
Yeah, I think we're out of time, but yeah, I appreciate any feedback on the KEP.
Okay. Thank you. See y'all next time.
Thank you.